All right. So in this case, I want us to have a continuation. Remember, we were working with our paper one. The first time we had to work with the first part of our paper. So we're just gonna move on, continue with the questions that we are given. We managed to work from question 1 up to question number 8. So this is a continuation. Like I said, I'm gonna quickly rush through the questions that we were given. So that is the first part, question number 9. So we are given on 9a, express x squared plus 6x plus 5 in the form. All right, so this format that we are given, we do understand that whenever you're given this format, it is whereby you have to complete the square. So in that case, you must apply or complete the square in order for you to obtain such a format. So it is going to depend with the way that you complete the square. Remember, we've got formulas that you can use, or you can use the normal way of completing the square. All right, so given this part, which is x squared plus 6x plus 5, remember, when you have to complete the square, the first thing, the coefficient of x squared is supposed to be a 1. So that is exactly what we are having. So in this case, we are going to simply determine half of the coefficient of x, which is half of a 6. Then we square that half that we have determined, meaning to say half of 6, which is 3 squared, and 3 squared, that is a 9. So you can just write it as a 9, which is fine, or you can just focus with the 3 squared. Remember, you are going to have this as x squared plus 6x. You complete the square from here. This is where the part that you are focusing, where you want to add to be a perfect square. So you're going to add the 9, which is the perfect square that you obtained. Then you must subtract that same 9. Why are we subtracting, adding and subtracting at the same time? This is for us that we do neutralize. We want to neutralize our question back to the original question that it was. Okay, 9 minus 9, that's what? That's a 0. Meaning to say we still have our original question, because this is simply like a 0. But do not cancel that because you see 9 minus 9, that is no. You are going now to factorize this part from x squared plus 6x up to 9. You do factorize. So to factorize this is the simpler way that you're going to do. You are simply going to have your x, all right, from the x squared, and the 9, which is from the 3 squared. So that is going to be plus 3 squared, like this. You have factorized. In this manner, you have factorized. So you just focus with the part of x squared, which is x, the part of 9. Do not worry about it. So you can use the normal factorization. I'm not saying it's wrong, but that is the simpler way that you simply work with, because we shall work with more questions. Then you try to apply the traditional way of factorization. Then sometimes we've got fractions. So just take the part that you squared here and the part of x, which is the part of x squared. So it's x plus that part squared minus a 4. From these two, we can subtract, add minus 9 and a 5. That is going to give us a negative 4. So as we can see, that is the format that we are given here. The part of ax plus b to the exponent of 2, okay, plus a c. So this is the format that you're given. When you're given this format, it does not mean this is supposed to be a positive. This also is supposed to be a positive. No, these are just signs that are using there. It can be a negative. It can be a positive here. Does not matter at all. All right. B, hence or otherwise state the turning point. Hence, it's a continuation. Otherwise, you can use any other method to determine the turning point. So we do understand that whenever we have got this format that we are given, it follows that the turning point is going to be represented with this part of B given as a negative. So it's going to be negative B. It was a positive. Then the C remains as it is. So this is the condition of the turning point from this format of completing of the square method. So if you are using the hence method, it's just a continuation. So you take this, you put a negative there. So it's going to be a negative 3. then the part of C, as we saw here, C is remaining as it is. It's not affected. So meaning to say this number is not affected. It is just going to remain as it is. So therefore, our turning point in this case was going to be -3, -4. That's how we can take it direct like that. Hence, otherwise, you can opt for any other ways. Remember, if you're given y is equal to, which is a function, x squared plus 6x plus 5 like that, you can determine the coordinate of the turning point, which is the x coordinate of the turning point. At the turning point, we can use minus b over 2a. At the turning point, the first derivative with respect to x is equal to 0. Guys, that is otherwise. You can use any other way that you do understand. But hence, it's just a continuation. Then C, find the set of values taken by y is equal to this part for real values of x, for real values of x. Okay, the moment we given something about real values, okay, let's just have our equation. We are given that y is equal to 1 over x squared plus 6x plus 5. If they wanted you to have a continuation from what you had before, they were going to write that statement again. And so otherwise, this is a question on its own. It has nothing to do with what you have done before. If it had to be a continuation, they were going to state that. At that part, they can do. They can remind you that you can continue. But in this case, there's nothing like that. But we need the condition where x is supposed to be real values of x. What is it that you consider real values? Remember the quadratic part. Nature of roots. Ax squared plus bx is equal to 0. The discriminant is supposed to be greater than 0 for the real values of x. If we have got an equation in this format, ax squared plus bx plus c is equal to 0. Remember, your discriminant b squared minus 4ac supposed to be greater than 0. Okay, but is it like can we have that format here? We are stuck because there is a fraction. So we are actually stuck with the format, the presentation that we are seeing here. But since we are to find the values of y, therefore, let us just formulate an equation because it's already a quadratic. But what we just need is to cross multiply. So we're just going to cross multiply this y times x squared. That's yx squared. Y times this 6x. So it is going to be 6yx. Remember, we need the format of ax squared bx. So we need x squared x. Okay, so we're going to have x squared x like that, followed by a constant y times 5. That is going to be 5y is equal to 1 times 1. That's a 1. So still we have got something somehow, but this is not equal to 0. It must be equal to 0 for us to apply this. So we're going to have yx squared plus 6yx plus 5y. Then we transpose the 1. That will be a -1 is equal to 0. So as we can see, we have got the part of x squared, part of x, and of that of the constant. So meaning to say what we need there are the coefficients so that we refer to our A, B, and C. We need A, B, and C. So this is going to be our A, this is going to be our B, and this is going to be our C, the constant where we do not have X, the whole of this part, that is your constant. You have a constant there. So you're talking of the A, the B, and the C. So if truly the values of X are supposed to be real, the discriminant b squared minus 4ac is supposed to be greater than 0. And the b, we have got this, that is 6y squared minus 4 times a, which is y in this case, times c, which is 5y minus 1. The constant must be greater than a as 0. We now have something else. It's no longer, that's why we're asked to calculate the values of y. We're talking of the y values there. We have formed an inequality. It's no longer of x there. Inequality of y. So you need to solve this inequality. So back to the ways that you do understand. So you're going to square this 36 squared there. It's going to be 36y squared minus 4y. So this is same as we've got minus 4y like this. All right, the whole of this part. So meaning to say that will be minus 4y times 5y. So that is going to give us minus 20y squared minus 4y times this minus 1. That is going to be a positive 4y, which is greater than a 0. We can also simplify this, the part of 36 and 20y squared subtract. That is going to be 16y squared plus 4y in this case is greater than 0. Remember, when you are solving, what you're going to need at this stage is to obtain the critical values when you treat 16y squared plus 4y as it is, that is greater than 0, to be equal to 0. Or you can factorize first, it's up to you, or you can just find your critical values by solving. So there, we are going to need the critical value. So I can just factor out y in that case. Yes, you can factor the highest common factor, it's up to you. This is 4 here. So you can just factor y there. That will be 16y plus a 4 is equal to 0. So meaning to say y is equal to 0, or from this other bracket, if we solve 16y is equal to negative 4, you can just divide by 16 by 16. So that means y will be negative 1 over 4. All right. So we've got negative 1 over 4 there. So I want us to understand that these are the critical values that we have got in from this case. We've got our critical values where y is equal to 0, or where y is equal to minus 1 over 4. Using any method, you're going to use the graphical method to obtain the exact solution, which is the inequality. It's up to you. So in this case, I'm just going to use the graphical way, considering this as our x. Yes, we know this is y, but just consider as x so that you do not have confusion, all right? So we've got a negative value. Let's say that's where we've got our negative 1 over 4, and this is where we've got our 0 there. Just take it the way that you present your graph of x, all right? So this is a positive, so we are going to have something of this nature, okay, because we've got a positive there. So for which values are we going to obtain a greater value, greater than 0? You know, this is above, x-axis above, so this side. So you're talking of above. If it was less than, we're talking of this region, below this axis. So like I said, just treat this as the normal way as you treat your x, but knowing that this is y. So these values compared to the minus 1 over 4, how are we going to compare y to the minus 1? We are saying y is less than minus 1 over 4. What about these values? They are greater than a 0. So meaning to say y also is going to be greater than a 0. So that is condition. So we do not have an exact value for y. There are values, set of values that we are talking about there. So that is the condition. Find the set of values. That is an inequality that is to be solved. It's not a direct value where y is equal to 2 or y is equal to 3. No, it's not like that. All right. Then on the other part, you were given on question 10, back to complex numbers. So also you shall try to work with these topics separately, our complex numbers also. We are given f of x. And from this f of x, show that minus 5i is a root of f of x, which is equal to 0, is a root. All right. This is our f of x. Just gonna consider it here. We are given that f of x is x to the exponent of 4 plus x cubed plus 23x squared plus 25x minus 50, like this. So we have a condition where we need to prove that x is equal to minus 5i is a root. This one is a root. For it to be a root, it must be x is equal to. So what is it that we know? Remember, yes, these are complex numbers, but this does not change the concept that we understand about our factor concept, the factor. If we do understand the factor concept that f of a, when it is equal to 0, therefore x minus a is a factor. That concept is supposed to work. We do understand that. So if we have got x which is equal to minus, and we are saying it's a root, That is the condition of this part here of f of a is, it means the x that you are talking about is the x which is equal to a, the one that you substituted here. And this is what you are given. So if we are to substitute this, that is f of that x that you gave, which is f of a, and obtain a 0 like this, that means x is equal to minus 5a, 5i is a root. All right, so let's try. F of minus 5i is going to be equal to what? In place of x, you substitute minus 5i. Plus, in place of x, minus 5i to the exponent of 3. In place of x, minus 5i again, so that's 23. Minus 5i to the exponent of 2. In place of x and so on. So this is going to be 25 into minus 5i like that, minus 50. So we have substituted where x was in our expression. So let's try to simplify and see what we are going to obtain at the end. So this is going to be -5. So guys, you have to simplify, remembering that we are under complex numbers, and under complex numbers, I squared is equal to a -1. I squared is -1. Remember that. So just consider to say, if I squared is -1, what about I to the exponent of 4? It means I have got I squared raised to the exponent of 2, meaning to say I have got -1 to the exponent of 2, which is a 1. Remember, I squared is -1. So this I here raised to the exponent of a 4 is simply going to give us a +1, which is multiplied to this -5 to the exponent of 4, which is 625. So that was going to be 625 times 1, which is 625. All right. We move on to the next step here. We have got -5 raised to the exponent of a 3. And that is going to be -125 times I to the exponent of 3. All right. Let's talk about this I to the exponent of 3. Remember, we know the value of I squared. So separate this in terms of I squared. So it's the same as I squared times I like that. We cannot separate the same way like the previous way, because that one, it was an even number. So for an odd, just target I squared times I. That is, I squared is what? -1 times I, which is simply minus I. So meaning to say, when I is raised to the exponent of 3, this is what we have. We are going to obtain minus I. All right, so that is minus and a minus. That was going to be a +125 I like that. All right. Let's move on to the other part, which is -5 raised to the exponent of 2. That was going to be +25 times I squared. Remember, I squared is what? -1. So that was going to be a -1. So meaning to say, we obtained -25 times this 23, which is outside. That was going to be -575. Okay. So on that case, you do not have I there. All right. There's just expansion. 25 times -5. That is -125 I, then -50. All right. So that is where we are, and we can simplify these collecting like terms. The 125 I here at the -125 can cancel. That is 625 -575 -50. That was going to give us a 0, this whole part. So meaning to say, that's a 0 there. So therefore, we can conclude that the x, which is equal to -5i, this one that we had, is the root, is a root. It is a root of what? F of x. Is a root of f of x. We are not talking of a factor. A factor, that is when we consider it in brackets x plus 5i like this. There we are now talking of a factor. But the root is the solution, is the exact value of x. So if they wanted to refer in terms of factor, they're going to ask you, prove that x plus 5i is a factor. So from this stage, then you write it like this. Therefore, x plus 5i is a factor, but that one is a root. So you just end at this stage, all right? So that is what we had in that case. We just need to work with more questions. Just try to revise as much as you can. Then hence, solve the equation. Hence, it's a continuation, like I said before. F of x is equal to 0. So for this f of x, to be equal to 0, this f of x, for this to be equal to 0, what is the condition? That's the question. What is the condition? Solve, that is to find the x values. You have to solve an equation. So to solve, you must be able to factorize your f of x. So in this case, you have to try by all means to factorize f of x. All right. So before you do that, there is something about the complex numbers, because in this case, remember we are saying x is equal to minus 5i is a root. And I was saying, therefore, x plus 5i, if you consider that, you have got x, which is equal to maybe minus a like that, which is the one that you substituted to obtain as a minus a. It means x plus a is a factor. Just introduce a negative. If it is f of a is equal to 0, x minus a is a factor. So there it was a negative. So therefore, x plus 5i is a factor. This one, we are talking of a factor. Okay? But the concept now of these complex numbers is that because you're going to divide, guys, remember what you're supposed to do. Like maybe x plus 2 is a factor of a certain expression that I'm given, a whatever that I have. I'm supposed to apply the long division with that factor. But in this case, take a closer look. You have got a complex there. You have got imaginary. You're talking of I there. How are you going to divide? It's going to be difficult. So it follows that we must understand our complex numbers as well. We must understand our complex numbers as well. It follows that if we are given x plus, or let's say x is equal to a plus bi like that. That is, x is equal to, it's a solution that you are given. This is a solution. This is the root. X is like this one. X is equal to minus. This is a root, a solution that you're given. If this is one of the roots, therefore, x is equal to a minus I like this. It's going to be, okay, let me just use a bit there so that we do not have a confusion. Let's just say bi there, then we're going to have minus bi like this. It is now a factor also. From this condition, x is just introduce a negative on the imaginary part. So therefore, x is equal to a minus bi is a root. Is a root also. That is for the complex. So this is what we are given before. With this condition, we can conclude that from this x, which is equal to minus 5i as a solution, there is also another solution. If x is equal to minus 5i like this, therefore, another solution is supposed to be x is equal, because we do not have this part. Don't get confused of this part of a. A is the real part. The negative is introduced on the imaginary part, and this is the imaginary part. So if you introduce a negative here, it becomes a positive. So that is 5i. So therefore, x is equal to 5i is also a root. So this is also a root of what? Of f of x. Okay. Now that we do understand that x is equal to 5i is a root, x is equal to minus 5i is also a root like what we had. As we need to focus with the factor. The factor is, guys, when you divide with the factor, the bracket of x plus 2, the bracket of x. Those are factors, not the roots. So from the roots, we need the factors. Like what we said here. If this is a root, x plus 5i is a what? Is a factor. So from this one, we also need the same condition from this. Therefore, we are going to take x minus 5i. It was a positive, so you just put a negative. So x minus 5i is a factor. So there we are talking of a factor. All right. Given two factors, this is a factor and also this is a factor. You can combine these factors, guys. X minus 2 into x plus 2. If these are factors and we need other factors, you can combine these two factors. You can combine them. So it follows that from these two factors, also these two factors that we have, we can consider x plus 5i like this into the bracket of x minus 5i as it's also a factor. A product of factors, of two factors, also gives us a factor of that function. f of x. So it's also a factor, this product that we are seeing here. So the question is, what is going to be the resultant of this? All right, remember when dealing with complex numbers, guys, it's easier when given this condition. We know that it's a difference of two squares, but under complex numbers, if you are given this condition that you have got a plus and minus, you just take the part of x, you square it, then the constant, you just square it as it is. So this is x squared plus 5 squared, which is going to be x squared plus what? Plus 25. That's simple like that. Yes, you can expand your brackets, but just take the constant you add. Don't worry about the negative there, because the negative is cancelled by the I there, so you don't consider that. So in short, you just square x and the constant together. So that's how you can expand this, all right? That is in short. So remember, we are saying the product of two factors gives us a factor also. So it means x squared plus 25 is a what? Is a factor, just like what we had before. It is a factor. So if this x squared plus 25, guys, is a factor, we can take advantage of this to factorize now, because what was limiting us is to factorize with a factor which is having these guys, the I there, the imaginary values. How are you going to operate with the x plus 5i to divide with x plus 5i? It's difficult. So that we have what we are used to, guys. This is a normal algebraic term, a constant value, 25, the numbers that we are used to this condition. So now we can apply our long division to determine other factors from this one. You now apply your long division. So remember our long division. So it is going to be x squared plus 25 into f of x. And remember our f of x, the whole of that function that you're given of the x cubed, this whole part that we have there. All right. So we're going to rewrite our f of x as it was, x to the power of 4 plus x cubed plus 23x squared plus 25x minus 50. So I hope you understand the condition there, why we have to determine that combined factor, because remember, just to divide, you're dividing by x minus 5i here or x plus 5i. How are you going to suppose these are, we do not have complex here. These are normal, direct algebraic terms. So we also need to divide by a normal algebraic expression or term that you're given them. All right, the long division does not change. First term versus term, first term, let's divide. That's x to the power of 2. So meaning to say that will be x to the power of 2. Then you multiply it back here to everything. X to the power of 2 times this. That's x to the power of 4. You add powers there. X to the power of 2 times this, 25. That is going to give us 25x squared. So we do not have the part of what x cubed. So you can just write this as 0x cubed like that. All right, let's subtract and see what we're going to obtain. This one and this one was going to cancel. There we have got 1x cubed minus 0. That's 1x cubed, which is simply x cubed there. All right, 23 minus 25, that is minus 2 x squared. Then we can drop these terms that are remaining plus 25x minus 50. All right, let's divide. We still have that allowance in this case to divide. We can do our division again. This is to x squared, x cubed divided by x squared. We're going to remain with 1x there. So that is plus x. Then it multiplies everything. That will be x cubed. X times 25, that is going to be 25x. So this is 25x here, meaning to say we do not have a part of x squared. Just write this as 0x squared. Then subtract. All right, so by subtracting, that was going to cancel this x cubed and x cubed. Then minus 2 minus a 0 there, that's a minus 2. That's minus 2 x squared. The 25x and 25x cancels. You remain with a minus 50 that you're going to drop down here. We divide again. The first term always, guys, do understand this concept. First term to the first term. So that is minus 2x squared divided to x squared. So this will cancel. You remain with a negative 2. It multiplies everything. Negative 2 times x squared. That's negative 2x squared. Negative 2 times 25. That's negative 50. That will be a negative 50 there. Then if we subtract, we can see that these two terms are actually the same. I mean, these two part that we have what we have here, this is just the same. So by just subtracting, that will be a 0 there. And take note, you are dividing by a factor. So definitely your remainder is supposed to be what? A 0. When you are dividing by a factor here, you must obtain a remainder of a 0. That is, you are not obtaining anything on the remainder. If you obtain any other value, it means you divided wrongly, or you are using what you refer to as a factor there. You are using a wrong factor. All right. So this whole f of x, we do understand that it's going to be a combination of what we're dividing with to answer. Just like 6 divided by 2 is 3. 2 is a factor of 6. 3 is also a factor of 6. Remember that. The product of these two numbers, 2 and 3, is supposed to give us a 6. So it's the same condition. This f of x here is supposed to be equal to the product, what was dividing, which is just like 2 and 3. So we're dividing by x squared plus 25. And we got what? X squared. This time we are not getting numbers like what we are used to say divide this, we get numbered. Like we are getting an expression, but it's still the same concept. So a factor times a factor, this is going to give us that f of x as it was. So the question here is that remember, we are still factorizing. We're still factorizing. We just want to factorize first. So f of x is going to be equal to x squared plus 25. We can't factorize this further, this one. There's a plus there. It's not a minus. So that's not a difference of 2 squares. That's why you saw that we had those complex solutions, is because of that. This cannot be factorized. Into this part, we can factorize this. The coefficient of x squared is 1. Let's consider the constant, which is 2, negative 2. So we are going to need the products, which are the factors of negative 2. These products of negative 2 must add up to a positive 1, the coefficient of x, which is a positive 1. So which part, when you add here, you must obtain a positive 1. That's 2 and what? Negative 1. If we add there, we must obtain, or you're going to obtain a positive 1. So we've got x plus 2 and x minus 1. Do revise your factorization again from your O level. That is the concept. So this is our whole of f of x factorized. But is it the question? No. We were factorizing this so that we can obtain the solution. It is easier to work with the part that is factorized. All right? It's easier for us to obtain the roots when we've got something that is done. To work with this, it was going to be difficult. How are we going to find the x values there? Because the question is to solve the equation. To solve, that is to obtain the x. What is the x value? So in this case, remember, already we have got the first solutions here. X is equal. This is a solution. That is to solve. X is equal. When you solve an equation, you obtain x value. X is equal to 2. X is equal to 3. X is equal to whatever that you're given. So it means when we're simplifying the first part where we're given the first root, that solution, it's a solution. That's a root. X is equal to minus 5i and x is equal to, we have the roots already there. So we have got the roots already from this here. When we are to solve this now for f of x to be equal to 0, it means this whole part must be equal to 0. So this x squared plus 25 is equal. It's already solved, this one. That is the one that we have got those roots. The x is equal to 5i. The x is equal to minus 5i. Those two solutions. It's from this one, the complex one. So meaning to say from these two, we are going to obtain the other solutions. Take the 2 to the other side. It becomes a minus. So x will be minus 2. Or x is going to be what? Minus 1 to the other side. That will be a positive 1. So meaning to say, we are just adding these two from the two that we had, those complex solutions. That is the condition. To solve, you must obtain the x values. So that's how you work with your complex solutions with the part of a factor theorem. You are working back to your factor theorem, but it has to do with the complex numbers. Now you have to get back to your complex numbers, understand how, or the concept of the complex numbers. As we saw, there was a part where we had to use a condition which we are taking from our complex numbers. All right. There we are given question 11. There are two functions, there are three functions actually there. The functions f, g, and h are defined as f of x, x squared plus 2x, then g of x, 4x plus 1, then hx 1 over x minus 3, and we also have those domains, whatever that you're given. Find on A, GHX from this function. All right. We do understand that GHX, it is from the GX, you are going to substitute HX. That is what it means. The GX, remember this is your GX here. This is our GX, which is 4x plus 1. GX was given as 4x plus 1. This is what we're given. It's 4x plus 1. So here when they're saying GHX, it means in place of x, substitute HX. But HX is not just a term, it's a function. So you're going to substitute it as a function, as that function that is 4 into, in place of x, you substitute the whole function of HX as it is. The whole function of HX, this is your HX as it is. So the function of HX is what? It's 1 over x minus 3. You substitute that one plus a 1. So that's it. This is same as over 1. So you can just cross multiply there. The numerator 4 times 1, that is going to be 4 over 1 times x minus 3. That's x minus 3 plus a 1. So this is our GHX that you're given. You can simplify this. It's up to you. Have it as a single fraction. That is it. Remember, 1 can be written in terms of the denominator that you are given there. If you are given 1 over 2, you can write 1 as this denominator of 2, which is 2 over 2. So if you are given the denominator as x minus 3, it means you can write this 1 as x minus 3 over x minus 3. Why are we doing this? So that we can simply add. Remember, if the denominators are the same, you are simply going to combine the numerators as they are. So that is 4 plus x minus 3. So that was going to be 4 plus 4 minus this 3, which is 1. So meaning so we've got x plus 1 over x minus 3. So that was going to be our answer there, where x in this case is limited, okay, from the denominator that you are given. Remember, our denominator cannot be equal to 0. So it means x minus 3, just equate it to 0. It means x is equal to 3. When x is equal to 3, this function cannot operate. The denominator cannot be equal to a 0. So meaning say our x is going to be a real number, which is fine, but x cannot be equal to 3. Once our x is equal to 3, this function cannot operate. So that is what we had in that condition. All right, so we move on to the other part, which is the inverse this time, to find the inverse of f of x. All right, where is our f of x? Our f of x is a quadratic expression, which is x squared plus x. That is our f of x there. All right, let's see. We need the inverse there. So that's item 2. We are given our f of x as x squared plus 2x, and you need to determine the inverse. All right. We do understand that for the inverse, what you need is to interchange the x and y, then we make y the subject. So in this case, it is going to be difficult that you operate it that way. Like, what you're going to need is to complete the square. So you can complete the square at this condition. You can complete the square because this is here is same as y is equal to x squared plus 2x. So remember the first part, interchange. Where there is y, you have it in terms of x. So meaning say x is equal to y squared plus 2y. After interchanging, what are you supposed to do after interchanging? You are supposed to make y the subject. Make y the subject. But how are we going to make y the subject? Because it's impossible. If you factor out this y here, you're going to remain with y plus 2. So it's impossible for you to make y the subject as it is like this. But remember your completing of the square method. I want you to consider something when it was in terms of x. When you complete the square, you're going to obtain something of this nature, ax plus b squared plus c. If you consider the way that it is it was taken from a condition of ax squared plus bx, where we've got x squared and x there. But now we just have a single x there, just a single x. So by completing the square, it is going to give us a single part of y there, instead of us having a y there and another y there. So we must complete the square. So we're back to the completing of the square. X is equal to y squared. Remember, it's already a 1 there, half of this 2. Just like that part, that will be 1 squared. So we're going to add this 1 and also subtract 1, like I explained before. Then we factorize this. So meaning to say x is going to be equal to factorize, that will be y, and you focus with 1. So that's why the 1 is taken from 1 squared. So it's still that 1 that we had. So that's y squared minus 1. Okay, let's make y the subject. It's now easier there. Can transpose the negative 1 this side. That will be a positive 1. So meaning to say x plus 1 is equal to y plus 1 squared. We can remove this square by introducing the square root. So that is going to be the square root, both sides, to get rid of the square that you're given there. So that is the square root here. And you also have the square root there. All right, so we can take this y plus 1 as it is. Remember, guys, we have reintroduced the square root so that we get rid of the square. So meaning to say y plus 1 is equal to the square root of this part, which is the square root of any number is plus or minus. So that will be plus or minus the square root of x plus 1. So as you can see, guys, we're almost there. We can make y the subject by transposing the 1 to the other side. That will be a negative 1. So therefore, we can conclude that y is equal to minus 1 plus or minus the square root of x plus 1, which is the inverse in that case. That is the inverse of x. Okay? So as we can consider, you will see that it is very, very important that you do understand the concept. Interchange x and y, make y the subject, but in making y the subject, there is a process that we have to go through now. If it was just a direct expression or direct, but they're just going to apply it direct like that, but they were to apply completing of the square. So working with the quadratic, you must think of that. So even we can state our domain in this case. Remember, x, when limited under the square root, we are supposed to obtain values that we can determine. We can determine their square roots. The square root of 0, that's a 0, but the square root of minus 1 does not exist. So we must think of a condition when this is equal to 0 and x plus 1 is equal to 0. It means x will be minus 1. At a condition where x is minus 1, you obtain a 0 in this side. So what is going to affect this to give us negative values? Is it going to be bigger values or lesser values than minus 1? Is it going to be values like minus 2, minus 3? Those values, minus 2, minus 3, they'll give us negative values under the square root. So in this case, no matter what we are going to have in the presentation, our x is supposed to be less than minus 1. Our x is not supposed to be less than this, but it is supposed to be greater than or equal to minus 1. Meaning to say, at minus 1, our function can operate at values greater than minus 1, talk of the 0, 1, 2, our function we can obtain the square root of any positive, but we can't obtain the square root of any part that will give us a negative, like now we've got square root of minus 2. That's where we now talk of the complex solutions. So in that case, our x is supposed to be a value bigger than or equal to minus 1 for this function to operate. All right, so that is our function. In this case, the inverse part need to, when you're working with the inverse. All right, so there, let me check. This one does not affect this other part. Okay, let's just remove this. Then B item 1, sketch the graph of y is equal to the modulus of gx, showing clearly the intercepts and the end points. All right, so we need the intercepts and the end points from the domain that we are given. Remember, we've got the domain limiting the x values from our gx there, -2 up to +2. All right. Up to +3, sorry. So this is B item 1. the modulus of a function, that is, remember, we are going to have it, this is just a sketch, guys. So I'm just going to have it this way. That's we've got our x and y there. So we do understand that we are supposed to take this function of gx as it is. So let's work with the function of gx. The function of gx, which is y is equal to 4x plus 1. If you are to consider this, we can have the x-intercept, the y-intercept. The x-intercept, when y is equal to 0, we are going to obtain the x value, which is -1 is equal to 4x divided by 4. So x was going to be -1 over 4. So meaning to say it is going to have the x-intercept maybe at -1 over 4 somewhere there. -1 over 4. The y-intercept, when x is equal to 0, y is equal to 1, meaning to say y is equal to 1. Our function was supposed to be like this, guys. We're supposed to have our line like this, going like that. That is what we're supposed to have. But because of the modulus concept, remember, we are going to focus with positive values only. So we are going to take this part, because it's that is the part of our positive, this one, as it is above the x-axis, this part, going like that. But now we are limited because we are supposed to have something like this going this side, guys. We're supposed to have something like this. So what is going to happen now? We are simply going to multiply these values that we are having this side by a negative. Remember, modulus means plus or minus. So meaning to say, by multiplying every value that we're going to have this side by a negative, we are going to have these values now corresponding this way, guys. That is where we are going to have them. Remember, this were negative. You just multiply these ones by a negative. They are now positive in the other way. So it is simply, this is what I'm trying to say. You are simply sketching two graphs. The graph of y is equal to 4x plus 1, and the graph of y is equal to -4 into 4x plus 1, like this. That is what is happening, which is affected above the x-axis. That is the only condition now, above. So meaning to say, you focus with where the graph is now starting to be, where the function is on the x-intercept. So this part, we are going to remove it. We are not going to work with this. All right. So above, we've got this part. This is direct. The part of y is equal to what? 4x plus 1. And this other side will be of y is equal to minus into the bracket of 4x plus what? Plus 1. That is the concept of the modulus. But they also need us to show the end points. The end points are now determined by the domain from the gx. The domain, we have got the first part starting at -2. So when x is -2, what is going to happen? Y is equal to, x is -2. So in place of x, you're going to substitute -2. So that's 4 into -2 plus a 1 like this. So y is going to be -8 plus 1, which is -7. But you multiply this value. It was supposed to be a -7 this side. So you're going to multiply it by a negative. Remember, guys, where it is the -2, because it's this side. So it is affected by the graph of y is equal to minus. So you're going to multiply this by a negative. Y is going to be a 7. So -2 was going to correspond with a 7 somewhere there. Okay. -2 versus a 7. Again, just this is just a point, guys. You can even indicate it anyway. So that's -2 versus a 7. Okay, just gonna put it maybe there. -2 versus a 7. So this is where we are. And the last part, 3, when x is equal to 3. So if we are to consider this other side where we have got a 3, 3 is on the positive side. And on the positive side, we are working with the graph of y is equal to 4x plus 1. So we are not going to multiply this by a negative. We're just going to take as it is. 4 times 3, that's 12 plus 1, which is 13. So it means this was going to correspond when x is 3. This was going to be 13. So that is the point that we are going to indicate also. 3 versus 13. All right. So that's just like that. It's intercepts are there. Y-intercept, x-intercept. This one, we are not going to have it this side. We have it above the x-axis. It must be above, on top of the x-axis. All right. Then from there, the question is later on, hence state, because already we have this, hence it's a continuation, state the what? The range of this modulus of f of x, the range. So the range, because we have got our starting point here from the negative, ending here at 3. This is the domain, that is the operating values of x. But what about the range, which is the operating values of y within this function? Our y is operated from where to where? Where is it limited? In, within. All right. So we're going to see that the least value of y is at 0 in the x-axis, where y is equal to what? To 0. Up to the end point, remember, when this was 3, y was equal to 13. This is the maximum value. Remember, at minus 2, we have got a 7. So comparing 7 and 13, the bigger value is at what? At 13. So y is supposed to be greater than or equal to 0 in this x-axis, but less than or equal to 13. That is the condition of our y values as the range. X values, that is the domain. This here, we are talking of the domain. The range, what is the limit in terms of y? Y is limited from where to where? Minimum value of y to the maximum value of y. X, the same thing, the domain, the limiting value for x from minus 2 up to positive 3. We are talking of the x values there. All right, so that is it, guys, for this one. Let us see. Other part, question number 12, an identity. Prove the identity. So to prove, as we do understand that it is, we're supposed to have the same answer, no matter the way that you're going to take, but you must have the same answer. So there we are given the cos of theta over 1 minus cos of theta. All right, this is supposed to be identical to this. All right, so I'm just going to take the left-hand side, in this case, the left-hand side. All right. So the left-hand side in this case, which is equal to this part, that is the cos of theta over 1 minus the cos of theta minus the cos of theta again, everything over 1 plus the cos of theta. So this is supposed to give us this on the right-hand side. So let's see. From the left-hand side, we picked the left-hand side. Then let us see what we can do. We can try to combine these. Okay, let's try to combine because we do not know what's going to happen there. 1 minus the cos of theta into 1 plus the cos of theta. That is our LCM or the LCD. Let's divide the 1 minus cos theta cancels, meaning to say you're going to remain with 1 plus cos theta multiplied to the cos of theta on top. Okay, minus, already there's a cos of theta there. So if we divide this 1 minus cos theta and this cancels, you remain with 1 minus cos theta. All right, this is where we are. The cos of theta times 1 is the cos of theta. The cos of theta times the cos of theta is cos squared theta. Minus cos theta times 1 is minus cos theta, and minus cos theta times minus, that's positive cos squared theta. Everything is over 1 minus, okay, let's just write, but that's a difference of 2 squares if you can notice, because there we can see that something is going to cancel there. We can leave it like that, but that's a difference of 2 squares. Remember, okay, 1 and 1 minus plus cos and cos. So this was simply taken from 1 minus cos squared theta, difference of 2 squares. Remember, a minus b into a plus b, giving us a squared minus b squared. That's a difference of 2 squares there. All right. So with this, we can combine the numerator, the cos of theta subtracts. There is a 1 and a 1. So that's 1 plus 1 on cos squared, which is going to be 2 cos squared. All right. So there we have got 2 cos squared theta over 1 minus cos squared theta. Remember, what we need is to obtain a cot squared at the end. 2 cot squared. And we understand this cot is from the cot of theta, is from the cos of theta over the sine of theta. So to have a cot squared, we must have a cos squared over a sine squared also. So we do not have that in the denominator, but the numerator is fine. There's a cos squared already. So how can we obtain something of a sign there? All right, let's go back to our Pythagorean identity. Cos squared theta plus sine squared theta is equal to 1. So what happened with this cos squared? By transposing it to the other side, you remain with the sine squared theta. Transposing this, it becomes a negative. That's 1 minus cos squared theta. So in place of 1 minus cos squared theta, there is a sine squared. So this whole part here, it's a sine squared. So that is 2 cos squared theta over a sine squared theta. That is what you have there. And remember what I was saying, if it is a cos squared over a sine squared, this whole part here, cos over a sine squared, is going to give us what? A cot. That's a cot squared. So meaning to say we are going to have 2 cot squared theta. All right, so this is exactly what we have on the right-hand side. That is, we have proven this. It is identical to what we have on the right-hand side. So proving of identities, as long you are to obtain the same thing, and that is the most important part. So make sure that you do understand the concept there. All right. Hence or otherwise, again, so we're going to work with the hence in this case. Hence or otherwise, we need to solve the equation. This whole part is equal to 1. Remember, this here, this here, this here is representing 2 cot squared when we proved this. So meaning to say we are going to start from the 2 cot squared, the one that we are seeing here. But they are saying these 2 cot squared, which is from the hence, these 2 cot squared x that we are seeing right now, this 2 cot squared theta, sorry, is now equal to 1. The whole of this part is equal to what? To 1. So that's the hence. So meaning to say I can remove this part, guys. It's not useful because we do understand where our hence is going to start from. All right. So we are going to start from where we have already proved. To even if you do not understand, maybe you failed to prove this one, at least try to solve this one. Where there's a hence and you proved something, guys, do not let these marks just go like that. 7 marks. You just work with the proof part that you already have. That's the hence, or otherwise, maybe if you want to use another way. All right, so that's we've got 2 cot squared theta is now equal to what? It is now equal to 1. For this interval, for theta being taken greater than or equal to 0 within 360 degrees, giving answer to the nearest degree. To the nearest degree, that's simply to the nearest whole number. To the nearest whole number, because our answers are in degrees. So to the nearest degree, that's to the nearest whole number there. All right, let's solve hence. I'm going to divide, there we've got a cot squared. So let's just try divide by 2 and say cot squared theta is equal to a half. Okay. We do understand that cot can be taken from many ways. We saw that part of a cot squared being taken from a cos squared over a sine squared. But working with this, we're going to have 2 trig ratios to work with. So let's avoid this one. Let's go back to another part. Remember, a cot of theta is taken from 1 over the tan of theta. So if it is cot squared, it's going to be 1 over tan squared of theta. A cot is 1 over tan. So at least working with a tan that we are used to is better. So that's 1 over a tan squared of theta. This is the same. We haven't changed anything. So it is equal to what? 1 over 2. Because we already have 1 over 2 there. So if 1 over tan squared theta is 1 over 2, what about a tan? Because this is just interchange there. Tan over this is 1. Tan squared over this, that's tan squared. 2 over 1. Just interchange. This is what you want. Instead of, yes, we can cross multiply, guys. So meaning to say tan squared theta is equal to what? A 2. So this is what I'm trying to say. In future case, you are given something like, let's say we have got something like 1 over tan of theta is equal to 3 over 2. And you want tan, just interchange. The tan of theta is equal, you interchange also this side. So it's 2 over 3, just like that. Just like that. All right. Anyways, there is a tan squared, not a tan. This is tan squared, not a tan. What about a tan? Introduce the square root to obtain a tan. So tan of theta is equal to the square root. And we do understand that the square root of any number that is a plus or minus. So it is going to be up to you the way that you're going to use it, there we need the exact root. This is not the general solution. We need the exact solutions. What is theta? What is the value of theta? The exact solutions. So it is up to you the way that you're going to work with, but I talked about the reference angle. If you are watching the other videos for netted and also for those grade 11, I talked about finding of the reference angle. The reference angle is simply the acute angle that you determine from the ratio that you're given, which is arctan, the square root of 2. Ignore the negative that you're given. This was going to give you 54.73 degrees. But remember, we are told to the nearest degree, that is to the nearest whole number. So we're just gonna round off to the nearest whole number, which is 55. So there we've got 55 degrees. So this is our reference angle, this one, the reference angle. How do you operate with a reference angle? I'm not going to use the general solution. If you want, you can use that. From the reference angle, you must understand now the quadrants. Remember, from the all students take calculus, whatever way that you want, all students take calculus. We can use this concept that a tan, where is it negative? Where is it positive? Because we need both conditions, being positive and being negative. All right, so this is positive, tan here it's positive. In this case, it's for sine and for cos, meaning to say tan here it's negative, tan here it's negative. So even if you do not understand because of the plus or minus, you just need, okay, I'm going to work with everything. But as we need to operate this properly. So let's start when positive. As you can see, there is a positive square root of 2. So when positive, our answer is going to be in the first quadrant and in the third quadrant, which is the exact value of theta. Theta is equal to reference angle in the first quadrant, and theta is equal to, remember here, we are going to add, that is 180 degrees plus the reference angle in this quadrant. So from the first one, your theta was just going to be 55 degrees. The reference angle is 55 degrees, and theta is equal to the reference angle. Then the second one, in the third quadrant where tan is a positive, our theta was going to be 180 degrees plus the reference angle, which is 180 plus 55, and that was going to be 235 degrees. When negative, this is what you are going to obtain. When this tan is a negative value, it means we are going to obtain the answer in the second and in the third quadrant. And in the second quadrant, remember, theta is equal to 180 degrees minus the reference angle. And in the fourth quadrant, theta is equal to 360 degrees minus the reference angle. So meaning to say, we can obtain another theta again from the second quadrant because tan is negative there. So it was going to be 180 degrees minus the reference angle, which is 55 degrees. So 180 minus 55, that was going to be 125 degrees. Then another theta was going to be 360 minus reference angle, where it is a negative. So it's going to be minus 55 degrees, our reference angle, and that was going to be 305 degrees. So these are the values of theta within the interval that we are given from 0 to 360. From 0 to 360, if you are given this type of a question from 0 to 360, just use your quadrants direct because these angles are taken from 0 to 360. So every angle is there here. Every angle is there. Unless if they give you another interval from minus 360 to 360, that's where now you can maybe think of using your general solution concept. But I'm not saying even if you use your general solutions here, you're not going to have the same answer. No, you're going to obtain the same answer. So therefore, our theta was going to be 55 degrees or 125, just going to have in this order 235, 235 degrees, and 305, or let's just say there 305 degrees within this interval from 0 to 360, from 0 to 360. So these are the typical questions on solving when you are solving a trigonometric equation. That's now an equation. An equation under trigonometry. So you consider the reference angle. Even if you were to use the general method, the general solution concept, you'd still work with this part. depending with the way that you understand. So I want us to do revise as many questions so that you have the concept of answering the question. The concept is much, much important than revising these question papers. We can do 20, but if you do not understand a concept from one, it's a waste. A concept here can answer 20 question papers because you have idea. So focus on having the concept. So you're going to work with these topics. I'm glad some of us, they are requesting, even though we have got a lot of things to work with. So guys, you must also remember, we have got a membership which is going on, even though now it's not currently for A-level. So we need to focus with membership first. Like members, if they request something, that must be done first. So you see the pressure that is there, but we are coming, we are working on it. We are working on everything to be on the ground. So just make sure you are with us, and also invite others wherever you are. Make sure that you come as many. If you also come in numbers also, it can also help us to work on more content, more videos, so that you learn. Can also use your device to learn with others at a school, at a college, wherever you are. Connect, link up with people. Do not be the one to obtain an A, or maybe you say, I want this level, I want to 5 points. No, do not be the one for that. All of us must have the same 5 points. Possible. Let us, all of us have that. It's not like if all of us have it, then something is going to happen to you. No. Destinies, futures are different. 5 points of yours and 5 points of another person will be used in different manners, different fields. Let's grow together. All right. So let's share the information in as much as we are trying, because we are trying. Actually, we are trying. By all means, I want to thank you guys for that. So yes, let's talk in the comment section, guys. I'm just going to find time when I have time. Work your content, work your videos as much as I can, So I want us to consider that. Let's share this information. Please do share to your friends, share to your colleagues. Yes, they need this information, guys. All right? Your colleagues, they need this information. As long as you see, as long as it's useful to you, it is useful to someone. Don't think it's not useful to my neighbor. No. Once it's useful to you, to someone else, it's going to be useful again, the same way it was useful to you. So do share. All right. So number 13, we are now given by sketching two appropriate graphs. Show that x cubed minus plus x minus 4 is equal to 0 years 1 root. All right. This is a question that you need to interpret the function that you are given. There are actually two functions. If you don't study that much, you think that it's just a single function. No, there are two functions there. Remember, this here is a straight line. This x minus, it's actually part of a linear function. X cubed, we're talking of a cubic function. So what if I was to write the same function the way that it is? All right, what if I was to write it this way? It is x cubed, as we are given, plus x minus 4 is equal to 0. Then we transpose so that we remain with the x cubed, which is the cubic function. So that will be x cubed is equal to, transpose this to the other hand, that will be minus x plus f4. What are we noticing here? We are noticing that a function of x cubed is equal to a function of x, y is equal to x minus 4, just like y is equal to y is equal to. And we do understand that if two functions are given, maybe I've got a quadratic and a straight line, at the point of intersection, that's where we have the roots. So using the same manner, we are going to have this as a sketch of two functions. So we're going to have this x and y there. So remember the cubic function y is equal to x cubed, guys. It is just like this. Gonna have something of this nature. Then it passes through the 0 there, increases these values going up. All right, so that is the sketch of y is equal to x cubed. You just need to revise also your sketch. For the graph of minus x, which is y is equal to minus x plus 4, that's a straight line graph. And we do understand for a straight line graph, we just need the intercepts, the x-intercept and the y-intercept. When y is equal to 0, x is going to be what? X is going to be 4. So meaning to say we have got a point at 4. What about when x is equal to 0, y is also a 4. So we've got a 4 there. Then we can join. All right. By joining this graph of y is equal to minus x plus 4, we can see that these two functions, they do meet at a certain point, and it's just a single point that we are seeing. It is not 2 points. It is not like what we expect to have 3 points. Like on a cubic function, you're supposed to have 3 possible points where they intersect. This one, they will just intersect at a single point. So that is by sketching, show that. So that is the condition. So you're going to have a root which we do not know exactly what is going to be the root, but we are going to have a solution or a root somewhere there representing x. All right. Then show that there is a root between 1 and 1,5. There is. We do not have the answer. We do not even know that root, but they're just saying show that the root is between 1 and 1,5. So it follows that whenever you are given this type of a question where you need to show that a root is between a given point, or we are given two roots, x is equal to 1 and x is equal to 1,5. These two roots, they are different, yes, but we want to see if a root lies in between these two. For you to notice that, you work with the change of sign. Whenever you substitute this and you also substitute this and there is a change of sign, it means that root lies in within. The root lies in between those two roots that you're given. There must be a change of what? Of sign. So you must note for a change of sign. Into our f of x, this one, x cubed, whatever that you had, f of x is equal to x cubed plus x minus 4. You take it as it is like this. Let's try if x is 1, we substitute that to be 1 cubed plus 1 minus f4. And that was going to give us a minus 2. F of 1,5. When this x is 1,5, you do the same thing to the exponent of 3 plus x, which is 1,5 minus f4. That was going to give us a positive, which is 0,875. So this is a negative. This here is a positive. There is a change of sign. Minus to plus, it can be plus to minus. As long as there is a change of sign, it therefore means the root lies between what you are given. So therefore, the root lies between these values that you are given, between x is equal to 1 and x is equal to 1,5. So we just know that the answer lies there. We do not have the answer exactly, but it lies in between. Then now they're saying, by using the formula, you are given the formula to use. Do not think of your own formula. Use the one that you are given there. They are saying by using this formula, x is equal to the square root of 4 over xn minus 1. Using this formula and taking x1 to be 1,37 as an approximation, the first solution to be 1,37. Approximate the root of this, correct to 2 decimal places. So how am I going to approximate the root? I'm already given a formula. So it's just a matter of substitution. So it means if this is maybe xn, there we are given this as xn here. So it means this must be xn plus 1. Like if you're given, if you want to find x2, xn plus 1, it means if this is 1, this will be 1 plus 1, which is 2. So it means for us to determine x2, we must substitute x1 here. That is what it means. Just in place of x, you substitute that x1 that you are given in place of this. So that was going to be the square root of 4 over our x1, 1,37 minus 1. Then use your calculator properly. This is the matter of your calculator. So there we are going to obtain a value 1,3855 and so on and so on. So I'm just going to use 4 decimal places, but that was 55 and so on. You do the same thing, x3, meaning so you substitute this value in place of x, just like what we had. So this time it will be like this, the square root of 4 over that value that you're given, 1,3855 minus 1 and so on. So you're going to obtain 1,3737 and so on. All right. So you're going to do the same thing. You substitute that 1,37 here. So you're going to obtain x4 and so on, which was going to be 1,3827. So if you were to notice, this was not going to change. It was a repetition, 1,3758, x5 and so on, 1,378. All right. Then x6 here, which is going to be 1,38 and so on. So it was a repetition. Look, there is 1,37, 1,38, 1,38, 1,37, 1,38. This one is 1,38, 1,38. There's something there about this. So this is going to approximate to 1,38 at the end to 2 decimal places. It was going to be like that. So in approximation, our x was going to approximate to 1,38. The repeating part, you round off, it was going to be 888. As you're going to see, round off this one, 88, and so on. So that is a better approximation that we can have to 2 decimal places, as we are given there to 2 decimal places. So you use the formula that you are given there, work with that formula to attempt the question. All right, question number 14. There we have got the equation that is we are working with an implicit function there. So this implicit function, we have got y squared minus 3xy plus 2x squared, which is equal to 6. They are saying show that the derivative of y with respect to x is equal to that part that we are given. All right, let's just try and solve here. So remember, on our implicit function, we need to find the derivative of y with respect to x. So we must find the derivative with respect to x. With respect to x. So we do also understand that whenever we are given the derivative with respect to x of a certain function of y to the exponent of n, we are going to differentiate this function with respect to y as it is, which is kn, y to the exponent of n minus 1, but multiply the answer by dy dx, because this is not of x, it is of y. So you differentiate it as it is in terms of y, but your answer must be multiplied by dy dx. All right. So if you understand this, it was not going to be a problem because there is a y squared. So it means for me to differentiate this, I'm going to have this as the derivative of y, which is 2y in that case. But multiply your answer by dy dx, because this function is not of what? It is not of x, this term. So it'll be like this. All right, let's move on to another part. We have got minus 3xy. That's a product. Listen. So there we are referring to a product. So we have got 3x and y there. That's a product. So meaning to say we are going to consider our u and our v. Remember the product. U, the first derivative of v, plus v, the first derivative of u. All right. So we are going to have minus, remember there's a minus there, u as it is, our u is 3x, times the first derivative of v, our v is y, just like how you differentiated y squared. You differentiate y, that's a 1, but whatever that you must obtain, you must multiply by what? By dy dx. Okay, the derivative of y is 1 with respect to y, but your answer times dy dx, so you must be careful there. Plus our v is y in this case. We're going to take our v as y as it is, times the first derivative of u, our u, which is 3x. The derivative of 3x is what? Is 3. So 3, there is x there. So when you are differentiating, guys, with respect to x, ax to the exponent of n, it is just a n x to the exponent of n minus 1. There is no dy dx, there is after. So you just differentiate as it is. There is no dy dx there, okay? Just the same way with 2x squared. So you just differentiate because it is with respect to x. So that will be 4x, okay? Which is equal to 6. It's a constant. So if you differentiate a constant, that's a 0 there. All right, so let's expand our brackets here since we have got brackets by a negative that we have got outside of the bracket. So that's negative times this part. That will be negative 3x dy dx. Negative times positive, that's a negative. 3 times y there, that's 3y plus 4x, which is equal to 0. So as we can see, we need to find dy dx. So we can factorize the part where we've got the dy dx, which is common in this case, because we can see that we have got a common term, dy dx. So we can choose to factor out this dy dx, and by factoring out this dy dx, you remain with the 2y minus 3x. That is 2y minus 3x into dy dx. And that must be equal to, take all these terms, they do not have anything to do with dy dx. Take them to the other side of the equation, the minus 3y to the other side, that will be a positive 3y. The 4x, it will be a negative on that other side. So we've got minus 4x there. Divide by the bracket, you are done. So this, you're going to divide by 2y minus 3x, divide by 2y minus 3x. So thus, we have got the derivative of y with respect to x, which is exactly that we were being asked there to show. This is exactly what we were given to show that this is going to be equal to this. So it's just differentiate the way that you are used to. All right. Number 14b, this was something else, guys. You needed to understand there your mathematical approach, because, all right, already dy dx, guys, we have it. We proved this, and this is the one that we are given. So I'm just going to remove this part because it's not going to help anyhow. Because we have the answer already here. So I'm just going to have it. Remember, you calculated this. We do understand that when you are given a question like this, to calculate or to determine or to find the equation of a tangent, we must consider the equation of a tangent. A tangent is just a straight line, y is equal to mx plus c. You determine m, which is a gradient. From this gradient expression, you can have m. But as you can see, you need the y value and you also need the x value to determine this m. And also, in order, we must have a point, guys. For you to solve, you must have a point like there, where x is 1. You must have a corresponding value of, but we are not given. They did not give us. They told us a condition that y must be greater than. We are not, guys, take note here. Take note of this. We are not given there. We are told y is supposed to be greater than when x is 1. So what can we do? Because we need that value of y because it's missing here. So this is what you're going to do. Into the original function where y squared minus 3xy plus 2x squared is equal to 6. Substitute what you are given and solve for that y. Because you are given that x is 1. So in place of x, I'm going to substitute a 1 here. So that is going to be y squared minus 3y in place of x there. That will be a positive 2. Transpose this to the other side. That's a negative 6 is equal to 0 because we've got a quadratic equation that we have just formed, which we need to solve for y. So by solving for y, now we can consider that condition that we are given. So by factorization, consider the coefficient of y squared being 1. When I have y and y there, the factors of negative 4, that will add up to a negative 3. So we need factors of negative 4, factors of negative 4, negative 4 and 1, 4 and negative 1, minus 2 and 2, 2 and minus 2 is just one and the same thing. These ones, which part? When you add, you are going to obtain a negative 3. So that's minus 4 and 1. If you add these two terms, we are going to obtain a minus 3. So we've got minus 4 and a positive 1 from our factors. Now we can determine the y values From the first bracket to the other side, y is equal to 4, or the other one, 1 to the other side becomes a negative, y is equal to a negative 1. They gave us a condition because they knew that there are two possible values of y there. But this y is supposed to be a value which is bigger than the 0, that is greater than a 0. So you must compare which one is greater than a 0. So y cannot be a -1, but y is going to be a 4 according to the condition that y is great. According to this, y cannot be -1. So meaning to say the y that we are going to take is the 4. So there we have got a conclusion that when x is equal to 1, y is equal to 4 from this condition. So it's a point that you are given there, 1, 4. That's a point where x is 1, y is 4. So having a point, what is it that is missing for us to obtain this? It is the gradient now, which is our m. So our m, the gradient from the gradient expression. And what is our gradient expression? The derivative that we obtained, the dy dx. That is representing our gradient expression. So by substituting the value of y in place of y, so that is 3, y is equal to what? A 4. So that's 3 times 4 minus 4x. That is 4 times, what is our x? It's 1. Everything over 2y minus 3x. So that is going to be 2 times the value of y. Remember, y is 4 minus 3 times x. And our x value there is a 1. Just like that. So meaning to say our m there was going to give us what? If you simplify properly, that was going to give you 8 over 5. This is the gradient. We have a point. We have the gradient. This is enough for us to obtain what? The equation of the straight line, because a tangent is a straight line from y is equal to mx plus c. Y is equal to m, which is the gradient, 8 over 5x plus c, which is the constant that we are supposed to determine from the value of x and y that you're given. So there, y is 4, where x is a 1. So in place of x, you're going to substitute a 1, 8 over 5 times a 1 plus c, which is 4 minus 8 over 5 is equal to the constant c. By solving this equation, we can obtain the y-intercept, which is our c, which was going to be 12 over 5. That is equal to c. So therefore, our equation in this case can be given as y is equal to mx plus c. That is y is equal to mx plus c, which is 8 over 5x plus the constant, which is the y-intercept that we calculated, and that is 12 over 5. So it depends with the format of the equation that you are going to have at the end. Are you going to have in the form of ax plus by plus c is equal to, we are not given using this format there. Just determine the equation. Answer, you write it in the way that you do understand. So these are the typical questions, exam questions that you can actually have. We need to revise on much of these questions because it is going to be a repetition. They're going to repeat similar questions of this nature. So by revising, like I was saying before, as many questions, you can understand the idea, like how do they want you to answer these typical questions. So that's it, guys, from Maths Zone African Motives. Till we meet again.